Welcome to part 4 of the analysis enhancement videos detailing combined LAMBPLAN. I'm Kate Rummery, and I'll be talking you through the validation that was carried out to ensure that combined LAMBPLAN is producing better and more accurate ASBVs. There are 3 parts to this section. First, we'll run through the validation, then we'll have a look at changes in accuracy and changes in breeding values. So when we have a look at validation, AGBU run a special analysis to check how well the breeding values out of combined LAMBPLAN are predicting future performance. So we use a partial data set, so ranging from 2000 through to 2022, and we use these animals to predict the breeding values of animals in more recent year drops. And what we look at is the correlation between this prediction from the partial data set to the prediction from the whole data set, including the phenotypes. And what we want to see is a correlation that's as close to 1 as possible. So in this graph, we have the results. We have the maternal, terminal, and combined LAMBPLAN data sets along the x-axis, and we have a number that ranges from 0 to 1 on the y-axis. And we want that to be as close to 1 as possible. What we can see is that the maternal and terminal data sets and evaluations have done a really good job in the past, and they've absolutely served industry really well. But what we're really excited to see is that the combined LAMBPLAN evaluation is doing an even better job. So it's produced a higher correlation, which is great, but also more consistency. We've broken those graphs down into breeds, so we can have a look at the different breeds and how they're performing in the new evaluation. So these graphs are exactly the same as the last ones, just tipped on their side. And we can see across the board for every single breed, there's an increase in the correlation for the combined LAMBPLAN results. We do see a tiny bit of variability in our composite animals and in the breeds that have a lower reference sitting behind them, which we'd expect. These breeds and certain trait combinations are more lowly recorded, so we expect more variability. The validation confirms to us that the new analysis, the combined LAMBPLAN, is performing better. We're getting more accurate predictions of future performance, and we're also getting more consistency across breeds and traits. Some traits, some trait and breed combinations with low recording are more variable. We'll have a look at the changes in accuracy now. So on this slide, we have 2 graphs. On the top, we have the terminal, and on the bottom, we have the maternal. And on the x-axis, we have breeds. So these are breeds. So 16 is a Poll Dorset, 23 is a White Suffolk, and so forth through to our composite animals. And the same in the maternal. So we have Border Leicesters here, and our composite maternal and composite shedders up this end. We have the accuracy difference. So we have 0 here, which means there's no change in accuracy. And then we have some negative numbers, which means a negative change in accuracy. So accuracy's gone down, or a positive change in accuracy, where accuracy has gone up. So we have 2 traits, post-weaning weight in blue and IMF in orange. And the first thing that most people will notice is that in blue here, so post-weaning weight, for a lot of the traditional breeds, we've actually had a decrease in accuracy. And that's because we've changed a couple of different things in the model, like the heritability of post-weaning weight, but also post-weaning weight's correlation to other traits. And essentially reducing the heritability and changing some of those correlations has resulted in lower accuracy for that trait. But for most traits, including IMF in these graphs, the accuracy will go up with combined LAMBPLAN. And this is because there is a larger reference sitting behind the data. If we now move on and have a look at changes in breeding values, we have an example here. So these are the size of the 2023 drops. So they're an accurate group of animals for 2 traits, post-weaning weight and intramuscular fat. And this particular one is just looking at terminal animals. And what we're looking at on the x-axis is the traditional terminal evaluations, ASBVs of these animals. And on the y-axis, we're looking at the combined LAMBPLAN ASBVs for these same animals. And what we want to see is a nice straight, tight line that indicates very little re-ranking. And that's exactly what we're seeing. So these lines are pretty straight and pretty tight. So there's not going to be a lot of re-ranking of animals in combined LAMBPLAN, particularly for highly accurate animals. We have the same thing for maternals. So these are the exact same graphs, but for maternal animals. And we do see a tiny bit, I guess, more re-ranking in the intramuscular fat trait here across all of those breeds. And that's because of the smaller reference and the lower recording of these traits. So wherever there's low recording, particularly within breeds, we see, I guess, less accuracy, and it's harder to predict breeding values accurately.